To deal with data, understanding and differentiating data types is crucial. Let us look at what are the common data types we will deal with. Here, we focus on structured data. Generally, data are divided into quantitative data, which is given in numbers, and qualitative data, which may not be in numbers, or the numbers are just representing their qualitative features. Quantitative data are divided into two types, discrete data and continuous data. In simple words, discrete data means countable data, such as number of books read, number of workers in a company, number of items in an invoice, number of examination questions that one has answered correctly, and so on. A hint of detecting discrete data is commonly discrete responses are given as integers or whole number like 1, 2, 3, 100, 638, and so on. On the other hand, continuous data are often referred to as measurable data. For example, height, weight, temperature, length, thickness, amount of money, and so on. In most cases, continuous data can take any values which may be represented using decimal numbers, such as the thickness of the product is 5.4 centimeters. Let us move on to qualitative data, which consists of binary data, nominal data, and ordinal data. When a feature has only two categories of responses, we call it a binary data. For example, gender is a binary data because the responses are either male or female. Note that these two categories are in the same level or same order, which means there is no discrimination like male is better or higher than female, or female is better or higher than male. There is no such discrimination. Binary data is regarded as nominal data too. What is nominal data? When there are more than two categories, we call them nominal data. For example, petals color of hibiscus. Hibiscus petal color range from white to pink, red, yellow, purple, and even blue. Again, there is no discrimination between the colors, like we don't say that, oh, white color is better than pink color. All these categories are at the same order. Lastly, we have the ordinal data. Responses of ordinal data are in categories too, just like nominal data, but there are orders or levels between categories. For example, in an examination, students who get marks below 50 fall into the fail category, while students who get marks above 50 fall into the pass category. Do we say that the fail and pass categories are of same level or same order? We don't, because the pass students are indeed have better performance than the fail students. Another example of ordinal data is the hotel grades, 1 star to 5 stars. So here we can see orders. 5-star hotels are more luxury than 1-star hotels. So now, are you confident to differentiate these 5 types of data? Let's check your understanding in the knowledge check section. Finally, I would also like to introduce about the independent and dependent variables. Dependent variable is a variable or data that we are interested to explain or predict. For example, in a credit card churner case study, we may want to study about the churn of customers. So, customers churning, or whether they have churned or not, is the dependent variable. Another example, in an insurance company, A customer's insurance premium amount depends on many reasons. Here, the insurance premium amount is the dependent variable. You may be able to relate now. What is an independent variable? Independent variable is also named as explanatory variable, which refers to the variable that is used to explain the variation in the dependent variable just now. In other words, the dependent variable changes when there are changes in the independent variables. As in the example just now, whether a customer churn or not may depend on service quality, service prices, and so on. So, the service quality and the service prices are among the independent variables. Another example, customers' age, occupation, health condition history, and etc. are among the variables that affect the customer's insurance premium amount. So, they are the independent variables. As you can see in this picture, the amount of water affects the size of plants, number of leaves, and whether the plant is still living or dead. Therefore, the amount of water is the explanatory or the independent variable, while the size of plants, number of leaves, and whether the plant is still living or not are the dependent variables. However, commonly in data analytics, we try to focus on one dependent variable which we are interested to investigate.